Hello everyone, my name is Varun. I work as a math faculty in Narayana Educational Institutions. Today I am going to be discussing the solutions of JEE Advanced 2025 Paper 1. So let us go for the first question. Let R denote the set of all real numbers. Let AIBA belongs to R. Is giving all the coefficients are R for I equal to 1, 2, 3. He defined function f of x and g of x and h of x as given. And is saying f of x is not equal to g of x for every x belongs to R. He's saying it's never equal. So let us calculate f of x minus g of x now. What is f of x minus g of x? F of x minus g of x, when we do, we can notice that coefficient of x power 4 is getting cancelled. X cube into a3 minus b3 plus x square into a2 minus b2 plus 7x plus a1 minus b1. We will get it as f of x minus g of x. Now we're saying f of x minus g of x shouldn't have any real roots in x belongs to R. But if it's a cubic equation, there will definitely be a real root. So for it not to be a cubic equation, the coefficient of x cube must be equal to 0. So what is the condition we get here? a3 minus b3 is equals to 0. So if a3 minus b3 is equals to 0, he's asking coefficient of x cube in h of x. So let us calculate h of x. h of x is equals to f of x plus 1 minus g of x plus 2. We don't need to simplify the entire equation. We just need coefficient of x cube in it. So what will it be? X plus 1 whole power of 4 plus a3 into x plus 1 whole cube. There won't be any coefficient of x cube in the rest. Minus of g of x plus 2. What is g of x plus 2? G of x plus 2 is x plus 2 whole power of 4 minus b3 times of x plus 2 whole cube. So if you notice coefficient of x cube in this term and in this term, it will be a3 minus b3. But a3 minus b3 is equals to 0. So that gets cancelled. Coefficient of x cube only I am saying. And what is the coefficient of x cube in x plus 1 whole power of 4? 4x cube. And the coefficient of x cube in x plus 2 whole power of 4 will be minus 4 into 2 into x cube. So minus 8x cube. I'll get the term as minus 4x cube. Coefficient of x cube, I'll get it as minus 4. So the answer for this question is C. Let us go for the second question. This is a question based on probability. 3 students S1, S2, S3 are given a problem to solve. Consider the following events. At least one of S1, S2, S3 can solve the problem. It means P of S1 union S2 union S3. S1 can solve the problem given that neither S2 nor S3 can solve the problem. It comes under conditional probability. Some of them took it as and. And W is S2 can solve the problem and S3 cannot solve the problem. So it is S2 can solve the problem and S3 cannot solve the problem. When it comes to T part, it is S3 can solve the problem. We can notice S1, S2, S3 solve the question independently. So the events are independent here. So now let me take that the probability for student 1 to solve the problem as X, P of S1, I'll take it as X, P of S2, I'll take it as Y, and P of S3, I will take it as Z. Now let us just write the given conditions, whatever he has given. So P of U is half, it's P of S1 union S2 union S3. This is equals to half. And P of V is equals to 10, that is conditional probability. Because it is independent events, we can directly take P of S1 is equals to 1 by 10. That is X is equals to 1 by 10. And S2 can solve the problem and S3 cannot solve the problem. That is P of S2 intersection S3 dash. So that will be Y into 1 minus Z, that is equals to 1 by 10. And we didn't use the condition that union is equals to half. How can I solve it? So P of S1 complement, that is P of S1 union S2 union S3 whole complement will be P of S1 complement into P of S2 complement into P of S3 complement, because it is S1 complement intersection S2 complement intersection S3 complement, and because all these are independent events, I have the relation that 1 minus x into 1 minus y into 1 minus z is equals to half. 1 minus half, which is again equal to half. So he gave x is equals to 1 by 10. The mathematical relations we now have is x is equals to 1 by 10, y into 1 minus z is equals to y into 1 minus z is this part. He gave that as 1 by 12. Y into 1 by z is equals to 1 by 12, and he gave 1 minus x into 1 minus y into 1 minus z is equals to half. So, and is asking the value of z from this one. Probability for S3 to solve the problem will be nothing but z. So, what will it be? X equal to 1 by 10, if I substitute here, I'll get 9 by 10 into 1 minus y into 1 minus z is equals to 1 by 2. I'll get 1 minus y into 1 minus z is equals to 5 by 9, and y into 1 minus z is equals to 1 by 12. From these two I have to simplify z. If I divide these two, what will I get? 1 minus y by y is equals to 5 by 9 into 12. So 4 3s are 3 4s are 3 3s are, I'll get 1 by y minus 1 is equals to 20 by 3. So I'll get y as 20 by 3. I'm getting y as 3 by 23. So how to simplify the value of z? Substitute in y into 1 minus z. 3 by 23 into 1 minus z is equals to 1 by 12. So 1 minus z is equals to 23 by 36. That implies z is equals to 1 minus 23 by 36, which is nothing but 13 by 36. So this is the given answer. You're using the condition that the events are independent, and P of A union B union C complement, I use a formula for P of A complement intersection B complement intersection C complement, and I simplified this. Let us go for the third question now. Third question, like there were ambiguities, there were different keys with different institutes and all that also. There is a slight conceptual issue here. Let R denote the set of all real numbers. He defined the function as f from R to R by f of x is equals to 2 minus 2x square minus x square sine 1 by x if x is not equal to 0, and 2 when x is equals to 0. Then which of the following statements is true? So first let us check the differentiability at 0 here. So how to check differentiability at 0? F dash of 0 is right hand limit and left hand limit. Both what will it be? Limit h tends to 0. F of 0 plus h minus f of 0 by h. So I'll get minus 2h square minus h square sine 1 by h. 2 and 2 gets cancelled. By h I'll get. So this value will be equal to 0. F dash of 0 is equals to 0. From that I can't comment that x equal to 0 is a point of local minimum. The thing is, the definition of local minima is if it is having a local minima at some point c to c plus h, in that interval it must be decreasing. If it's a minima, c to c plus h it must be increasing, and from c minus h to c it must be decreasing. Only then I can say it attains a minima at c. So here the derivative should be continuous for that one. Only then I can comment that it decreases in the interval 0 to 0 plus h. So let me see what is f dash of x here. F dash of x in the vicinity of 0, we have to see what is happening. So what will f dash of x be when x is not equal to 0? So I can directly differentiate this function. I'll get minus 4x minus x square cos 1 by x into minus 1 by x square. So this gets cancelled. I'll get cos 1 by x minus 2x into sine of 1 by x. So now this cos 1 by x in the vicinity of 0, it will be attaining positive as well as negative values. So we can't comment about the sign of f dash of x here. So from that part, x equal to 0 is a point of local minima of f is wrong, because I can't define that in 0 to delta it is increasing or decreasing. The function f is not differentiable at x equal to 0 is also wrong, because it is differentiable. F dash of 0 is 0. there exists a positive real number delta such that f is decreasing on the interval 0 to delta. If that b part is holding true, even like local maxima part condition will also be true. So here b is also wrong, and the only thing I can comment is it's not an increasing function in minus delta to 0, because within minus delta to 0 in that range, cos 1 by x is an oscillatory function. It will be changing from minus 1 to 1 rapidly. Even though this value is tending to 0, as x tends to 0, this value changes from positive to negative values. So throughout that interval, f dash of x won't have a common sign, and hence it won't be increasing in minus delta to 0 as well as in 0 to delta. It won't be increasing, it won't be decreasing. Let us go for the fourth question now. Question based on matrices. He gave a matrix P which is 2 0 0 0 2 0 0 0 3. It's a scalar matrix, diagonal matrix with entries as 2 2 and 3. Transpose of a matrix X denoted by X transpose, then the number of 3 by 3 invertible matrices Q with integer entries such that Q into Q transpose equal to Y. He's saying Q into Q transpose is equals to Y. So Q will be an orthogonal matrix and PQ is equals to QP. So let me use this condition now. I'll assume my Q as ABC, DEF, GHI. So if it's an orthogonal matrix, what is the condition? The determinant should be equal to 1 or minus 1. Not just that part. This first row, AI plus BJ plus CK must be a unit vector. DI plus EJ plus FK cap must be a unit vector, and GI plus HJ plus IK cap must be a unit vector. And dot product of each row must also be equal to 0. Even across the columns it must be true, but we'll go by this condition. PQ, if I look at it now, 2 0 0 0 2 0 0 0 3 into Q. Q is ABC, DF, GHI. So what will this matrix be? 2A, 2B, 2C, 2D, 2E, 2F, 3G, 3H, 3I. This is PQ. QP is ABC, DEF, GHI into the diagonal matrix 2 0 0 0 2 0 0 0 3. So what will this matrix be? A into 2, 2A, A into 0, 2B, 3C, and then 2D, 2E, 3F, 2G, 2H, and 3I. So this matrix and this matrix must be equal. So what is the condition? When will it, if you can notice 1 1 element, 1 2 element, 2A, 2B, 2D, 2E all and 3I element are equal. The only thing which is different is 2C must be equal to 3C, 2F must be equal to 3F, 3G must be equal to 2G, and 3H must be equal to 2H. So the condition is C equal to F equal to G equal to H equal to 0. So let us construct a matrix now Q. Q will be of the form A, B, C, D, 0, 0, 0, 0, and this last element is I. So this must be an orthogonal matrix. So recall, orthogonal matrix means dot product must be equal to 0 for each row, and each row must be unit vector. So I will have only two possibilities, because 0I plus 0 into j plus I into k cap must be a unit vector. I can be only plus or minus 1. Coming to this ABCD part, he gave the entries are only integer entries, it can be possible. So a square plus b square is equals to 1, c square plus d square is equals to 1, and ac plus bd is also equals to 0. So when will this happen? With integer entries, it can happen only when the entries belong to minus 1, comma 0, comma 1. If it's 2, minus 2 or anything, a square value will be greater than 1. So let me take the cases now. If a is equals to 1, if a is equals to 1, what should happen? B must be equal to 0. B must be equal to 0. And also notice that if Q is an orthogonal matrix, its transpose will also be an orthogonal matrix. So across this two, that is a square plus c square must also be equal to 1, b square plus d square must also be equal to 1, and ab plus cd must also be equal to 0. So keeping this in mind, let us see what is happening. If A is equals to 1, B must be equal to 0. And in this part, if I substitute, if B is equals to 0, if I'm substituting, AC must also be equal to 0. So I'll get C is equals to 0 and D can be plus or minus 1. So here I'll have two cases. Similarly, if A is equals to minus 1, again B must be equal to 0, C is equals to 0, D can be plus or minus 1. Here I'll have two cases. And the last one, A is equals to 0. If A is equals to 0, B is equals to, you can substitute it in this part, C must be plus or minus 1, and if B is plus or minus 1, D must be 0. D is equals to 0, and here C is equals to plus or minus 1. So how many cases I'll have here? 4. So total number of matrices is 2 into 2 into 4 into, I will have two possibilities. So the total number will be 2 into 2 into 2 into 4. 4 into 8, 32. So total 32 matrices are possible. Let us go for the fifth question now. This is a question based on 3D. L1 be the line of intersection of the planes given by the equation 2x plus 3y plus z equal to 4 and x plus 2y plus z equal to 5. L2 be a line passing through the point and parallel to L1. M denote the plane given by the equation. Suppose that the line L2 meets the plane M at the point Q. Let R be the foot of perpendicular drawn from P to the plane M. Which of the following statements are true? So it's pretty straightforward, but it's just involving a bit of calculation. So let me find the line of intersection of the first two planes. I have to find its normal first. Sorry, the DRs of it. 2, 3, 1, 1, 2, 1. So I times of 3 minus 2, 1, minus a times of 2 minus 1, 1, plus k times of 4 minus 3, 1. So I'm getting the DRs of the line L1 is 1, minus 1, 1. And a point of intersection I have to find out. So if I substitute z equal to 0 for time being, z equal to 0 if I substitute, I'll get 2x plus 3y is equals to 4 and x plus 2y is equals to 5. So if I subtract them, I'll get x plus y equal to minus 1 and x plus 2y equal to 5. If I subtract, I'll get y is equals to 6 and x is equals to minus 7. Minus 7 plus 12 minus 14 plus 18 equal to 4. So L1 is x plus 7 by 1 is equals to y minus 6 by minus 1 equal to z minus 0 by 1. This is L1. Now L2 be a line passing through 2, minus 1, 3 and parallel to L1 is same. So what will L2 be? The point on it is 2, minus 1 and 3 and it is parallel to L1. So the DRs will be 1, minus 1 and 1. So this is L2. Now M denote the plane given by the equation 2x plus y minus 2z equal to 6. Suppose that L2 meets the plane M at the point Q. I have to find this intersection of L2 and M. If I am equating it to T, what is the value of a point on L2? T plus 2 minus T minus 1 comma T plus 3. T plus 2 minus T minus 1 comma T plus 3. This I have to substitute it in 2x plus y minus 2z equal to 6. So what is the point? T plus 2 comma minus T minus 1 comma T plus 3. This lies on the plane 2x plus y minus 2z equal to 6. 2x plus y minus 2z equal to 6. So if I substitute, I'll get 2t plus 4 minus t minus 1 minus 2t minus 6 is equals to 6. So 2t minus 2t gets cancelled. T I'll send it on the right hand side. I'll get this as 4 minus 1, 3 minus 6 minus 3 minus 6. I'll get this as minus 9. So the point is minus 9 plus 2 minus 7 comma 9 minus 1 8 comma minus 9 plus 3 minus 6. So this is the point of intersection is Q. Now I was asking the length of the line segment PQ, distance between 2 comma minus 1 comma 3 and this one. So what will it be? Under root of 9 square plus 9 square plus 9 square. I'll get this as 9 root 3. So A is correct. The length of the line segment Q, R is asking. R be the foot of perpendicular from the point P to the plane M. So we have to find foot of perpendicular from P to M. P is this point and M is this one. Foot of perpendicular formula is h minus 2 by 2 is equals to k plus 1 by 1 is equals to L minus 3 by minus 2 is equals to, it's not image, it's just foot of perpendicular. So minus of 2 2s are 4, minus 1, minus 6 by 4 plus 4 plus 1, 9. So what am I getting here? Minus 3 minus 12 minus 4 minus 1 minus 3 minus 6 minus 9 minus 6 minus 15 minus of minus 15 by 9, which is nothing but 5 by 3. So what is this point h comma k comma L now? 10 by 3 plus 2, 5 by 3 minus 1 minus 10 by 3 plus 3. So this point is 16 by 3, 2 by 3 minus 1 by 3. Now is asking the distance between R and Q. So this is R and this is Q. I have to find the distance between these 2 points. What will it be? Under root of 16 by 3 plus 7 whole square plus 2 by 3 minus 8 whole square plus minus 1 by 3 plus 6. So 6 minus 1 by 3 whole square again. He's saying its value should be 15. So I just have to verify if it's an integer or not. 3 7s are 21 plus 16. 27, 37 whole square plus 24 minus 2. 22 square plus 18 minus 1, 17 square by 9 I'll get. So we are getting the calculation involving this part as under root 37 square plus under root of 22 square plus 17 square. Let me just check the units digit. 7 square 49, 9 plus 4 3, 3 plus 9 2. So it's an even number, and if I divide it by 2 it must be a perfect square. Equal to 15, area of triangle PQR, acute angle between the line segments PQ and PR. So distance between them is 37 into 37. 9, 6, 3, 1. Under root of 1369, 22 square is 484 and 17 square is 289 by 9. So I have to see if its value is equals to 225 or not. Units digit if I see, to just verify if it is 15 or not, under root of 225 I will be getting. So units digit of this one must be 5, 9 plus 4 13, 13 plus 9 21. Units digit is not equal to 5 and hence option B is wrong. Coming to area of triangle PQR, area of triangle PQR, what are the points? We know this point is P, this point is Q and this point is R. So let me find area of the triangle. Area of the triangle is half into PQ cross PR. So that will be 3 by 2 times of under root of 234. So I can even do it by determinant. I'll get this as half times of modulus of determinant of PQ. So what is PQ? I'll get this as 2 plus 7, 9, minus 1, minus 8, minus 9 and 3 plus 6, 9. And coming to PR part, I'll get 2 minus 16 by 3. ఇది పేజ్ సరిపోదు అంటే మళ్ళీ క్యాలిక్యులేషన్ ఎరేజ్ చేసి మళ్ళీ చేస్తాం. So let us go for the fifth question. It's a question based on 3D. Let L1 be the line of intersection of the planes given by the equation. Two planes is given. L2 be a line passing through point P and parallel to it. M denote the plane given by the equation 2x plus y minus 2z equal to 6. Suppose that the line L2 meets the plane M at point Q and R is the foot of perpendicular drawn from P to plane M. Then which of the following statements is are true? So initially I have to find the intersection of these two planes, which is L1. So that will be normal. I'm trying to find it. I, J, K, 2, 3, 1, 1, 2, 1. So I'll get it as I times of 1 minus J times of 1 plus K times of 1. This will be the direction of L1. And a point on it, if I have to find out, I'll just substitute Z equal to 0. Z equal to 0, if I substitute, I'll get 2x plus 3y is equals to 4. And x plus 2y is equals to 5. Intersection of these two, we get it as, if I subtract it, I'll get x plus y is equals to minus 1. Now again, if I subtract them, I'll get y is equals to 6. Y equal to 6 and x equal to minus 7. So the point is minus 7 comma 6, x and y. I'm taking z equal to 0. So L1 line will be x plus 7 by 1 is equals to y minus 6 by minus 1 is equals to z minus 3 by 1. Equation of line L2. It will be a line parallel to it and it is passing through 2 comma minus 1 comma 3. So what will it be? X minus 2 by 1 is equals to y minus 6 by, the point on it is 2 comma minus 1. So y plus 1 by minus 1 is equals to z minus 3 by 1. And m equation he gave it as 2x plus y minus 2z is equals to 6. If I try to find the point of intersection, that is if I assume this as equal to lambda, the point I'll get is lambda plus 2 minus lambda minus 1 and lambda plus 3. If I substitute that value of lambda here, the value of lambda I'll get is 2 lambda plus 4 minus lambda minus 1 plus lambda plus 3 into minus 2 is equals to 6. If I solve, I'll get the value of lambda as minus 9. So the point Q will be minus 7 comma 8 comma minus 6. Now I have to find R also. R is nothing but the foot of perpendicular from the point 2 comma minus 1 comma 3 to the plane, from the point P to the plane. So how will I find it? If I assume the point as x1 y1 z1, x1 minus 2 by 1 is equals to y1 plus 1 by 1 is equals to z minus 3, z1 minus 3 by minus 2 is equals to minus of 4 minus 1 minus 6 by 9. So the point R which I'll get is minus 12 minus 13 plus 4 minus 9, 9 by 9, this value will be equal to 1. So the point R is 3 comma 1 minus 1, 0 comma minus 2 plus 3, I'll get it as 1. Coordinates of R is x1 minus 2 by, sorry, the coefficient is 2 here. So this will be 4 comma 0 comma 1. R point we identified. Now area of triangle PQR if I need. This point is 2 comma minus 1 comma 3. One point is minus 7 comma 8 comma minus 6. And this point is 4 comma 0 comma 1. So I can either find the side lengths and I can use Heron's formula, or half into PQ cross PR if I do. I'll get the area of this as 9 root 3 square units. This is P, this is Q, and this is R. And is asking PQ. So I can use distance formula for to find the distance between them. Under root 9 square plus 9 square plus minus 9 square. So I'll get this as 9 root 3. QR length I'll get it as under root 11 square plus 8 square plus 7 square. 121, 64, 49. I'll get this as under root of 234. And PR I'll get it as 3 units. So the answer for this question is A, 9 root 3. Length of QR is not a rational number. Area of triangle PQR we got it as 3 by 2 under root of 234. Acute angle between the line segments PQ and PR we haven't found out. So what is PQ? PQ is, I'm trying to write, it's Q bar minus P bar. So Q is minus 7 comma 8 comma minus 6 minus of P is the given point P is 2 comma minus 1 comma 3. So what will this be? Minus 9 comma 8 plus 1, 9 comma minus 6 minus 3 minus 9. And PR. PR will be R bar minus P bar. So I'll get this as 11 comma minus 8 comma 7. So if I try to find the angle between PQ and PR, cos theta, dot product if I do, I'll get this as minus 99, minus 72, minus 63 by 9 root 3 into under root of 11 square. We found out PR distance. What is PR? PR is 3 units. So root 9 I'll get. So this value, if I simplify, I'll get this value as 1 by 3 root 3. And is saying its value will be cos inverse 1 by 3 root 3, but we are getting 1 by 3 root 3. So D is wrong, B is wrong. The given answer is A and C. Let us go for the sixth question. Let n denote the set of all natural numbers and z denote the set of all integers. He defined f and z from n to z and z to n respectively. F of n he gave it as n plus 1 by 2 when n is odd and 4 minus n by 2 when n is even. G of n is 3 plus 2n if n is greater than or equal to 0, minus 2n if n is less than 0. So let's proceed. We'll start with f and g. Later we'll go for the composite functions part. Notice that f of 1 is also equals to f of 2. Both are equal to 1 and hence it can't be a 1-1 function. If I try to look at the range, what will the range be? If I'm substituting odd numbers for n plus 1 by 2, 1 plus 1 by 2, 1, 3 plus 1 by 2, 2, 3 and so on. Union, in 4 minus n by 2 if I substitute even numbers. If I substitute 0, I'll get 2. If I substitute 2, I'll get 4 minus 2 by 2, which is 1, 0, 4 minus 4 by 2, 4 minus 6 by 2, minus 1, and then if I have 4 minus of minus 2 by 2, all set of integers I'll get it. So you can notice I'm getting like 1, 2, 3, all set of natural numbers here, and along with that I'm getting even the negative integers here. So I can comment that f is not 1, 1, but f is onto. So this statement is true. Coming to C option, g of n is 3 plus 2n if n is greater than or equal to 0, minus 2n if n is less than 0. When n is less than 0, can minus 2n1 be equal to minus 2n2? It can't be possible. And when n is greater than or equal to 0, 3 plus 2n1 equal to 3 plus 2n2 can't be possible. Can these two numbers be equal? For n less than 0, if I'm getting some minus 2n1, and for n greater than or equal to 0, some 3 plus 2n2, it can't be equal because one is an odd number and the other one is an even number. So g of n is always a 1-1 function. But coming to range, we can notice in the range of g, what is the set of numbers I'll get? In this 3 plus 2n part, if I substitute values which are greater than or equal to 0, and the domain is only integers, so 3 plus 2 into 0, I'll get 3, 3 plus 2, 5, 3 plus 4, 7, and so on. Union, when it comes to the negative integers, I'm having minus 2n. So n equal to minus 1, if I substitute, I'll get 2, 4, 6, 8, and so on. The thing is, it can't be equal to 1 anywhere. So, but I defined it from z to n. The range is not equal to the codomain and hence g is not an onto function. C is wrong. Coming to A option, g circle f is not 1-1 and g circle f is not onto. Let us recall a statement here before we proceed. G circle f is 1-1 implies f is 1-1. What is the contrapositive statement for this one? If f is not 1-1, then I can say g circle f is also not 1. Here we have this condition that f is not 1-1. So I can also conclude that g circle f is not 1-1. Is not 1-1. Similarly, I have the statement g circle f is not onto. If g circle f is onto, we know that g must be onto. Now, what is the contrapositive statement for this one? G is not onto, which is happening in this case. This implies g circle f is not onto. So what can we comment? That even A part will be true. Coming to B part, f circle g is not 1-1, but f circle g is onto. Let me verify it. The thing is g is 1-1, so f circle g can be 1. But coming to f circle g is onto, in the range of g, I'm having only 2, 3, 4, 5, 6 and so on. So f of this, if I'm trying to write f of g of x, this g of x range will have values only from 2. So I'll miss the value of f of 1. What is the value of f of 1? F of 1 is equals to 2 in this part, in f of g of x, I'll get f of set of the values 2, 3, 4, 5 and so on. So f of 1 value is missing, but that will be attained in f of 2. F circle g is not 1, 1 condition. Let us verify. I have to see if f circle g is 1, 1 or not. We can notice that g of x will be a 1, 1 function, and f of x, the g of x range, we don't have any 1 here. The issue we are getting in this question is only because of this element. F of 1 is equals to f of 2 is equals to 1. But if 1 is missing in that element, we can notice for each value of g of x, I'll get a unique value of f of x. And hence, the condition f circle g is not 1, 1 is wrong. And the answer is A and D. Let us go for the 7th question now. Here he gave two complex numbers, 1, 2 and 0, 3. He's saying PA is equals to 2 times of PB. So Apollonius circle condition. So let me take a straight line which contains the point 1, 2 and the point 0, 3. 1, 2 and 0, 3. So one is A and the other one is B. So he's saying PA is equals to 2 times of PB. So I have to find the point. Apollonius circle will be the locus. I have to find the point which divides A and B internally in the ratio of 2:1 and externally in the ratio of 2:1. So what will this point be if it divides it in the ratio of 2:1? 2 into 0 plus 1 into 1. 1 by 3, 6 plus 2, 8 by 3. And the point which externally divides it will be minus 2:1. So minus 2 into 0 or 2:-1. 2 into 0 minus 1. So I'll get this as minus 1, 2 into 0 plus 1 into minus 1 by 2 minus 1. So I'll get this as minus 1 by 1. And the other point will be 2 into 3, 6 minus 1 into 2 by 1. 6 minus 4, I'll get it as 2. Now these two will be the endpoints of the diameter of that Apollonius circle. So its midpoint will be nothing but midpoint of these two harmonic conjugates, which one divides internally and externally. That will be the center of the circle. So what is the midpoint of 1 by 3, 8 by 3 and minus 1, 2? What will the midpoint be? Center. 1 by 3 minus 1, minus 2 by 3, I'll get it as minus 1 by 3. 2 plus 8 by 3, 6 plus 8, 6 plus 8, 14 by 3 by 2, I'll get it as 7 by 3. 2 times of 3 minus 1 times of 2 by 2 minus 1. 6 minus 2, 4 by 1. 4. I'm getting this point as 4. So 4 plus 8 by 3 by 2. I'll get it as 2 plus 4 by 3. 6 plus 4, 10 by 3. So circle with center minus 1 by 3, 10 by 3. Coming to radius, it will be half of the distance between these 2 points. What is the distance between those 2 points? Under root of 1 plus 1 by 3, 4 by 3 whole square, plus 4 minus 8 by 3 whole square into half. That will be the diameter. So what will I get? Half into under root of 16 by 9, 12 minus 8, 4, plus 16 by 9. So I'll get this as 4 by 3 into root 2 by 2. 4 by 3 root 2. 1 root 2 if it gets cancelled, I'll get 2 root 2 by 3. S is a circle with radius 2 root 2 by 3. Let us go for the next question. Let the set of all relations R on the set ABCDF such that R is reflexive and symmetric and R contains exactly 10 elements be denoted by S, then the number of elements in S is. So the thing is, he's saying it should be reflexive. If I try to write the matrix here, starting from like A element, AB element and so on up to AF element, BA element, BB element and so on up to BF, and finally FA, FB and so on up to FF. Total I'll get 6 into 6, 36 ordered pairs. Within this 36 ordered pairs, he's saying all the diagonal elements must be present. So already 6 elements are there because it is reflexive. And how many elements are left now out of this 36? 36 minus 6, 30, and half of it will be 15. So now if I have to select 4 elements more, because it is symmetric, if A comma B element is selected, B comma element will automatically come. Similarly, if A comma F element is selected, F comma A element will automatically come. So can I say out of this 15, if I select any 2 elements, 4 elements extra will come along with the 6 elements, which is A, B, B and so on up to FF. In order to add 4 elements, I just need to select 2 elements out of the upper diagonal. So the answer will be 15 C2, which is 15 into 14 by 2, which is 105. So let us go for the 9th question now. For 2 points m and n in the xy plane, let mn bar denote the vector from m to n. 0 is the unit vector. P, Q, R are distinct points in xy plane such that SP bar plus 5 times of SQ bar plus 6 times of SR bar equal to 0. E and F are the midpoints of PR and QR. So now, because it involves only lengths here, I can shift origin as per my convenience. I'll take my origin at R bar. If I take my origin at R bar, what is the relation I'll get? P bar minus S bar plus 5 times of Q bar minus S bar plus 6 times of R bar is 0 bar minus S bar is equals to 0 bar. So P plus 5Q by 6 plus 5 plus 1 by 12 is equals to S bar. This is the relation we have. Now he's saying E and F are the midpoints of, let me draw the diagram first, R, P, Q. So this I'm taking it as origin, this will be P bar, this will be Q bar, and he gave SS P plus 5Q by 12. Then E and F are the midpoints of PR and QR. So length of the segment EF, what will length of EF be? Modulus of P minus Q by 2. Coming to ES part, length of ES, what will it be? S bar minus E bar. What is S bar? P plus 5Q by 12 minus E bar. E bar is P by 2 or minus 6P by 12. So I'll get this as 5 times of modulus of P minus Q by 12. So what is length of EF by ES now? P minus Q by 2 into 5 times of P minus Q by 12 I'll get. So this is non-zero, I can cancel it. I'll get 12 by 10, which is 1.2. So the answer for this question is 1.2. Now let us go for this question. S be the set of all 7-digit integers that can be formed using the digit 0, 1, 2. For example, he's saying it should be a 7-digit number. The number of elements in S such that at least one of the digits 0 and 1 appears exactly twice his same. So let me count the cases. We'll use inclusion exclusion principle here. 0 is counted, exactly 2 zeros are coming, plus exactly 2 ones are coming, minus the cases in which 2 zeros, exactly 2 zeros and exactly 2 ones appearing cases will subtract it. So first we'll divide it as A, it's P of A plus P of B minus P of A intersection. Coming to P of A, it's exactly 2 zeros. So out of 1, 2, 3, 4, 5, 6, 7, exactly 2 zeros must come in, it shouldn't come in the leading digit. So in this 6, I'll select any 2 places, 6C2, say I selected this place and this place. Once I fill zeros, the rest has no restriction, 1, 2, 3, 4, 5, 5 elements. It can be filled with any of 1 or 2. So the total number will be 2 power 5. This is N of A. We just need to count the cases here. We don't need to calculate the probability. So N of A is 6C2 into 2 power 5. N of B is the case in which 2, 3, 4, 5, 6, 7. Exactly 2 ones appear. So if exactly 2 ones appear, out of this 7, initially I'll take that there's no restriction on 0. I'll take that it can occur in the leading digit also. So out of this 7, I'll select any 2 places, 7C2. Now in the remaining places, 0, any of 0 or 2 can occur. So into 2 power 5. From this I have to subtract the case in which 0 is occurring in the leading digit. If 0 is occurring in the leading digit, what will happen? In the remaining 6, there should be 2 ones. So 6C2 and say this is 2 ones. In the remaining 4, there is no restriction. So there I'll get 2 power 4. This is N of B. Coming to N of A intersection. N of A intersection B is exactly 2 should come, exactly 2 zeros should come, exactly 2 1s should come, and the rest should be 2's. So I have to fill the numbers with 2 zeros, 2 1's, and the rest must be 3 2's. So how can I fill it? Again, I'll assume that 0 has no restriction. It can come in the leading digit also. In that way, I'll get 7 factorial by 2 factorial into 2 factorial into 3 factorial. From this, I'll subtract the cases in which 0 is occurring in the leading digit. If 0 is occurring in the leading digit, the rest can be arranged in 6 factorial by 2 factorial into 3 factorial. So now I have to calculate n of a plus n of b minus n of a intersection b. So I'll get what is n of a? 6c2 into 2 power 5 plus 7c2 into 2 power 5 minus 6c2 into 2 power 4 minus 7 factorial by 2 factorial, 2 factorial, 3 factorial plus 6 factorial by 2 factorial into 3 factorial. So if I count this part, I'll get it as 62, 15 into 32 plus 21 into 32 minus 15 into 16 minus 7 into 120 by 4. That 7 into 120 by 4 minus 210. This is 720 by 6, 120 by 2, 60. So I'll get minus 150. So if I simplify this whole part, the result will be n of a, I'll get it as 62, 32 into 320 plus 160, I'll get it as 480, and this part will be 432. From this I have to subtract minus 210 plus 60 minus 150, so its value will be equal to 762. The total number of cases will be 762. Let us go for 11th question now. This is pretty straightforward question based on limits. Alpha and beta be real numbers such that limit x tends to 0, alpha by 2 into integral 0 to x 1 by 1 minus t square dt plus beta x cos x equal to 2. Limit x tends to 0. First, I'll substitute x tends to 0. Numerator and denominator both are tending to 0. So I'll use L'Hopital rule now. I'll get it as alpha by 2 into 1 minus x square whole power of minus 1 plus beta x cos x derivative is beta into x into minus sin x plus beta cos x by 3x square. He's saying this limit must be equal to 2. So denominator degree is 2. So numerator degree also I have to expand it till degree 2. Whichever degrees are greater than 2, I can neglect. So I'll get this as alpha by 2 into 1 plus x square plus beta x into minus x plus beta into, in cos x I need to write two terms, 1 minus x square by 2 factorial by 3x square is equals to 2. So here the constant should get cancelled. So what is the condition? What is the constant here? Alpha by 2 plus beta. This must be equal to 0. And coefficient of x square by coefficient of x square must be equal to 2. So what is coefficient of x square? Alpha by 2 minus beta minus beta. Alpha by 2 minus beta by 2 by 3 is equals to 2 I'll get. So here I'll get alpha plus 2 beta is equals to 0, and from this expression I'll get alpha minus 3 beta, 2 2s are 4, 3s are 12 I'll get. So I need to find the value of alpha plus beta. So if I subtract them, I'll get 5 beta is equals to minus 12. I need the value of alpha plus beta. So what is the value of alpha plus beta here? Alpha plus beta is minus beta. Minus beta is nothing but 12 by 5. So I'll get it as 24 by 10, which is nothing but 2.4. So I'm getting the value as 2.4. Let us go for the 12th question now. Let R denote the set of all real numbers. Let f from R to R be a function such that f of x is greater than 0 for all x belongs to R, and f of x plus y equal to f of x into f of y for all xy belongs to R. Let the real numbers be in AP if f of A31 equal to 64 times of f of A25 and He gave a summation. Then he asked the value of sigma I equal to 6 to 30 f of ai. So if f of x plus y equal to f of x into f of y, I'll assume f of x is k power x. It can be equal to 1 or 0 also, but clearly mentioned f of x is greater than 0. And he also gave the condition that f of a31 is equals to 64 times of this. So it can't be equal to 1 also. Now I have to find the value of k. F of a31 will be, a31 is the 31st term of the AP. So I'll get it as k power a1 plus 30d is equals to 64 into k into a1 plus 24d. So if I divide it by k power of a1 plus 24d, because it is greater than 0, I'll get the expression as k power 60 equal to 64, which implies k power d is equals to 2. K power d is equals to 2. He mentioned all f of x is greater than 0. That is why I'm taking only the positive value, as k power d is equals to 2. Now sigma I is equals to 1 to 50, f of ai is equals to 3 into 25 power plus 1. So what is sigma f of ai? K power a1 plus k power of a1 plus d plus so on up to k power a1 plus 49d. We can notice it is in GP with common ratio of k power d, and k power d is equals to 2. So how can I write this? K power a1 into r, what is the common ratio? K power d, which is 2. Total number of terms is 50 minus 1 by 2 minus 1 is equals to 3 into 2 power of 25 plus 1. So what is k power of a1 now? K power of a1 is equals to 2 power 25 plus 1. If it gets cancelled, I'll get 3 by 2 power 25 minus 1. 3 by 2 power 25 minus 1. Now the result is asking is sigma I equal to 6 to 30. Sigma I equal to 6 to 30 f of a. So this will be k power a1 plus 5d plus k power a1 plus 60 and so on up to k power of a1 plus 30d. Sorry, a plus 29d. The total number of terms are 29 minus 4, 25. So it's again in GP. The first term is k power a1 into k power of 5d into total number of common ratio is again k power d, which is 2 power 25 minus 1 by 2 minus 1, which is equals to 1. So k power a1, you substitute the value 3 by 2 power 25 minus 1 into k power 5d is 2 power of 5, 32 into 2 power of 25 minus 1. So this and this gets cancelled. 3 into 32, I'll get the value as 96. So the answer for the question is 96. 13th question, it's a bit lengthy. Let y1, y2, y3, he gave 3 functions and he gave the differential equations separately. He gave its constants also. And is asking limit x tends to 0 plus y1 of x, y2 of x into y3 of x plus 2x by this part. So x tends to 0, we can notice that denominator is tending to 0. The numerator also must be tending to 0, or else it won't be tending to a finite value. So I have to find y1, I have to find y2, I have to find y3, and then I have to find the product of y1, y2, y3. There is a shortcut which involves, like at x tending to 0, dy1 by dx is equals to 0. I can use that result and do it, but it may not work for all the questions, so I'm going by the regular method only. So y1, y2, y3. Let me solve the first differential equation. dy1 by dx is equals to sine square x into y1. So dy1 by y1 is equals to dx into sine square x is 1 minus cos 2x by 2. Dx into 1 minus cos 2x by 2. So if I integrate this expression now, I'll get ln mod y is equals to dx by 2 is x by 2, and here I'll get minus sine 2x by 4. So if I integrate this part, I'll get y1 is equals to e power of x by 2 minus sine 2x by 4 plus some constant k, I'll write it. He gave y1 of 1 is equals to 5. So if I substitute that, I'll get 5 is equals to, or I'll substitute the integration constant and this one only. ln mod y is equals to this plus k. In this, if I substitute y1 of 1 is equals to 5, I'll get ln phi is equals to 1 by 2 minus sine 2 by 4 plus k. So k is ln phi minus half plus sine 2 by 4. So y1 function will be e power x by 2 minus sine 2x by 4, and k value is ln phi minus half plus sine 2 by 4. Now let us go for y2. dy2 by dx is equals to cos square x into y2 is given. So I'll have ln mod y 2 is equals to half into cos square x. I can edit as 1 plus cos 2x by 2. So I'll get x by 2 plus sine 2x by 4. So x plus sine 2x by 2 plus c2. Again, if I substitute the constant, I'll get this function y2 as e power of x by 2 plus sine 2x by 4. He gave the constants c2. He gave y2 of 1 is equals to 1 by 3. So if we use that condition, I'll get it as minus ln 3 minus half minus sine 2 by 4 I'll get if I substitute x is equals to 1. Similarly, the differential equation for y3, dy3 by y3 is equals to integral of 2 by x cube minus 1 dx. So I'll get this relation y3 as e power of minus 1 by x square minus x plus 1 plus ln 3 minus ln 5. Upon substituting the constant, we'll get this relations. It involves too much of calculation. I wrote the final result. So y1, y2, y3 if I multiply, y1, y2, y3 if I multiply, all these terms will get cancelled and it will just get reduced to e power of minus 1 by x square. E power of minus 1 by x square I will get. So if I use this condition, limit x tends to 0 plus, I'll get the limit as limit x tends to 0 plus e power of minus 1 by x square plus 2x by e power 3x into sin x. E power 3x into sin x if I have. X tending to 0 plus, you can notice this value will be tending to e power minus infinity. So even if you write its expansion, you'll get 1 minus x tending to 0 plus, it tends to infinity. We can't use expansion here. Its value is equals to 0. And if I divide it by x here, e power 3x value will be like a non-zero value. I can neglect it. If I divide it by x, I'll get e power minus 1 by x square by x plus 2 by sin x by x. So this value will be tending to 0. I'll get it as 2 by 1 and hence the value is equals to 2. E power 3x into sin x, y1, y2, y3, all the terms will get cancelled and I'll get e power minus 1 by x square. Yeah. So let us go for question number 14th now. It's a question based on statistics. He gave values and its corresponding frequencies. He gave its sum of frequencies, median of the frequency distribution he has given, and is writing alpha and beta, and variance is denoting it by sigma square. So now let us write our readings now. If the sum of the frequencies is 19, 5, 7, 8, 9, 12, the rest f1 plus f2 will be equal to 7, and is saying median of the frequency distribution is 6. So if you arrange it in an order, that is 4, 4, 4, 4, 4. Here I have 5 elements. Total, if the frequency is 19, 19 by 2 is 8.5. So 8 readings, 9 readings, 9 readings. I have to see what is the middle reading. So 5 4s are done. Next I'll go for 5s here. 5, 5 and so on. I'll have f1 readings. And then I'll have 6 here, which is only like 1 reading. And is saying this should be the median. So what can I say? Can I say the number of elements before 6, can I say it will be equal to 9? So the value of f1 is 5 plus 4. So f1 is equals to 4, f1 is equals to 4 and f2 is equals to 3. f1 is equals to 4 and f2 is equals to 3. So now let me write the table here so that all our calculations can be done easily. xi, fi, xi, fi, mod x minus a, xi minus ai into fi. All the readings I'll write down. This is xi, fi, xi, fi, mod xi minus a, the mean I'll calculate it, xi minus a into frequencies, xi minus a whole square to find the variance, and xi minus a whole square into fi. I'll write down all these values. Xi, he gave the readings as 4, 5, 6, 8, 9, 11, 12. Its frequencies are given as 5, 4, 1, 3, 2, 3, 1. Xi into fi I'll calculate now. Its product 20, 20, 6, 8 3s are 24, 18, 33, 12. And mod x minus a. Average we didn't calculate. So how to find the average? Average is sigma xi fi by sigma fi. So this part 20 plus 20, 40 plus 6, 46, 46, 50, 60, 70, 88, 100, 133 by sigma fi is 19. So 19 7s I'll get it. 19 into 7 9s is 63. So 7. Average will be 7. So what is modulus of xi minus a? 4 minus 7. Modulus I'm taking. So this will be 3, 2, 1, 1, 9 minus 7, 2, 11 minus 7, 4, 5. Now xi minus a into fi will be 3 into 5. 15, 8, 1, 3, 4, 12 and 5. Xi minus a whole square values will be 9, 4, 1, 1, 4, 16, 25. Xi minus a whole square into frequencies. Corresponding frequencies will be 9 into 5, 45, 16, 1, 3, 8, 48, 25. So sigma xi minus a into fi will be equal to 15, 8, 23 plus 1, 24 plus 3, 27 plus 4, 31 plus 5, 36 plus 12, I'll get it as 48. So we'll just check whatever is asking once we wrote the table. 7f1 plus 9f2. 7f1 plus 9f2, f1 is 4 and f2 is 3. 28 plus 27. 28 plus 27 will be 55. So this will be 5. 19 alpha. Alpha is mean deviation. What is the mean deviation? Xi minus a into fi is 48. Sigma xi minus a into fi by sigma fi will be the mean deviation. So this value will be 48 by sigma fi is 19. 48 by 19 into 19 is asking. If this is alpha, into 19 is asking. So that value will be 48. So 5 and 3, we have two options for now. This we can strike out and this we can strike out. R is 2, so we don't need to check it. But what is beta? Mean deviation above the median. So similarly, I can write down the median. Median value is 6. So again, I have to write the table of modulus of xi minus median into fi and I have to do it. But because R is only 2, I'm not solving that part. 19 sigma square. So variance I have to calculate. Coming to variance, xi minus a whole square into fi summation will be equal to xi minus a whole square into summation. Its sum will be equal to 146. 146. So sigma square is equals to 146 by 19. Is asking the value of 19 sigma square. So that will be 146. This is 1. So in which I have 5, 3, 2 and 1 is the answer. 5, 3, 2 and 1. Answer is C. So let me go for question number 15 now. Again a matrix matching question. The minimum value of n, we'll try to go by options first. 1, 3, 2, 5, 2, 1, 3, 1, 1, 3, 2, 4, 4, 1, 5, 3, 3, 5. Everything has like 2. So at least 2 questions we have to solve. In this, I find option R to be easy. The smallest natural number n which is greater than 5 such that x equal to 3 is a point of local minimum. So here I have x minus 3 whole power of n into x plus 3 whole power of n into a positive value. Now for it to attain a minima at 3, it should be in the form of x minus 3 whole square or x minus 3 whole power 4 and so on. So it must be an even number. It should be an even number which is greater than 5. So the smallest value will be 6. So option R will be 4. You can notice the graph of x minus 3 whole square or x minus 3 whole power 4 or something. 3 plus its value should be greater than the value at 3 which is 0. 3 minus also it should be greater than the value at 3 which is 0. So that is why n should be even there and it should be greater than 5. So for R I'll get 4. So R4 I have two options. S we don't need to solve, but I'll still verify. Cos mod x, I can replace it by cos x. So even though it's writing cos of mod of x minus k minus half, I can remove this part. And this part, sin mod x minus k, will always be non-differentiable at k. Sin mod x is always non-differentiable at 0. Similarly, sin mod x minus 1 will not be differentiable at 1. Whereas cos mod x will be differentiable at x equal to 0. So wherever I'm getting values, sin mod x minus k varies from 0 to 4. So it will not be a non-differentiable function plus a differentiable function will again be non-differentiable. So whenever sin mod x minus k is non-differentiable, its sum plus cos of that part will also be, it will be non-differentiable. So k from 0 to 4, I'll get total 5 numbers. So this is 3. So other than this, if I solve q part also, q part is also 1. I have to solve p part. Coming to 10x cube minus 45x square plus 60x plus 35. In between 1 to 2, if I differentiate that part, f dash of x, what will I get? 30x square minus 90x plus 60 I'll get. So this is 30 times of x square minus 3x plus 2. X minus 1 into x minus 2. So can I say within 1 to 2 the function is always decreasing? The function will always be decreasing. So now if I substitute f of 1 here, if I substitute f of 1, I'll get it as integer part of 60 by n, and if I substitute 2, I'll get f of 2 as integer part of 55 by n. Now we're saying it should be continuous within this interval. So I mean 60 by n and 55 by n both should be lying within like a range only. In 1 to 2, he's asking the minimum value of n for which it holds. We can like start substituting values. If I'm taking n is equals to 5 or something, its value is 11 and this value is 12. So as you increase slightly, if I'm substituting n is equals to 7, I'll get integer part of 60 by 7, integer part of 55 by 7. So in between there should not be any multiples of 7, but between 55 and 60 I have 56, and hence 7 is also wrong. Integer part of 60 by 8 and integer part of 55 by 8. You can notice between 55 and 60, I don't have any multiples of 8. 8 sevens are 56. So this value is 6.99 something, and this value is 56 is present. So then I'll go for the next best option, 60 by 9 and 55 by 9. Do I have any multiples of 9 between 55 and 60? I don't have. So these two integer values will remain the same. As my numerator varies from 55 to 60, for all values in between 55 to 60, its integer part will always be 6 point something. At 63 it will change. When the numerator is 63, or on the left side when it is 54 it will change. In between all the values it is true, and hence the answer is 9. So for this it is 2. So B will be the answer. Q part, if I have to solve the minimum value of n for which this is increasing function, x cube plus 3x is an increasing function. If I differentiate, I'll get 3x square plus 1. So LHS part should just be positive. So 2n square minus 13n minus 15 greater than or equal to 0 if you do. I think you'll get it as 2n minus 5, 2n minus 15 into n plus 1 is greater than 0. He's saying minimum value of n for which it is always true. So n should either be less than or equal, but he's saying n is a natural number. So this will always be true. N greater than 15 by 2. So I'll get n is greater than or equal to 8. So I'll get 1 here. 2143 is my answer. So let me go for the last question. 16th one. W, U and V be two vectors such that U cross V is equals to W and V cross W is equals to U bar. So he's saying W is perpendicular to U and V, and U is also perpendicular to V and W. So all three vectors are mutually perpendicular. If all three vectors are mutually perpendicular, I can write mod U into mod V is equals to mod W, and similarly mod V into mod W is equals to mod U. He gave mod W as root 6. So if I just multiply them, I'll get mod V is equals to 1 and mod U is equals to mod W, which is equals to under root of 1 square plus 1 square plus 2 square root 6. So we'll just look at this part. Achha, mod v we are directly getting it. Mod v square is equals to 1. So P2, almost all options are there except the last one. Now alpha equal to root 3 and alpha equal to root 2 is asking some particular cases. Now if you look at this part, this one, this one and this one. First we'll write the conditions whatever we have here. U and W must be mutually perpendicular and magnitude of U is root 6. So alpha square plus beta square plus gamma square is equals to 6 and alpha plus beta minus 2 gamma is equals to 0. These are the relations we have. Now when it comes to this part, if I'm trying to simplify this, like 0, 0, 0 will be a trivial solution for alpha, beta, gamma, but it's saying mod u is equals to root 6. And hence alpha, beta, gamma is non-zero. So its coefficients must be, that is, it must be homogeneous equation which has a non-trivial solution. So its coefficient matrix det should be equal to 0. So the conditions I'll have is modulus of minus t 1 1, 1 minus t 1 and 1 1 minus t is equals to 0. It's in the form of standard determinant. So either a equal to b equal to c or a plus b plus c will be equal to 0. So I'll get minus t equal to 1, that is t is equals to minus 1 or minus t plus 1 is equals to 0. That implies t is equals to 2. So t can be minus 1 or t can be equal to 2. So if t is equals to minus 1, we'll see what will happen. If t is equals to minus 1 and I substitute back in the original equation, I'll get alpha plus beta plus gamma is equals to 0. Alpha plus beta plus gamma is equals to 0. And what are the other two conditions I have? Alpha plus beta minus 2 gamma is equals to 0 and alpha square plus beta square plus gamma square is equals to 6. If t is equals to 2, if t is equals to 2, what will I get? Minus 2 alpha plus beta plus gamma is equals to 0 and similarly alpha plus 2 beta, alpha minus 2 beta plus gamma is equals to 0 and similarly alpha plus beta minus 2 gamma is also equals to 0. So let me look at the question now. He's saying if alpha is equals to root 3, what will happen? If alpha is equals to root 3, let me just check the consistency here. If alpha is equals to root 3, beta plus 1, if I subtract these two equations, what will I get? Gamma equal to 0. So I'm getting alpha plus beta is equals to 0 and alpha square plus beta square is equals to 6. So if I try to simplify this part, I'll get alpha as root 3, beta as minus root 3 or alpha as minus root 3 and beta as root 3. So if alpha is equals to root 3, I can say this condition is holding, that is t is equals to minus 1. He's asking the value of gamma. What is the value of gamma here? Gamma square is 0. So this will be 1, 2, 1. R is always 4. If alpha is equals to root 3, we solve this part that gamma is 0. He's asking beta square. The value of beta square, alpha square and beta square both will be equal. That will be equal to 3. So this is 1, 2, 1, 4. When it comes to alpha equal to root 3, I'll get the other case. That is, in this case, when I'm taking t is equals to minus 1, I'm getting the value of alpha as root 3. But if t is equals to 2, from this part, I'll get alpha square plus beta square plus gamma square is equals to 6. So if I'm subtracting these two, what will I get? Gamma gets cancelled. I'll get minus 3 alpha plus 3 beta is equals to 0. So I'll get all three values as equal. So I'll get 3 alpha square is equals to 6. That implies alpha is equals to plus or minus root 2. So converse is also true. If it's giving alpha square is equals to 2 or alpha equal to root 2, t value will be equal to 2 and t plus 3 value will be equal to 5. So the answer is 2, 1, 4, 5, which is option A. Thank you everyone.